Okay, I thought I would give you guys a sneak peek at my 1 meter glider conversion project. I've got quite a bit done with the airframe, and I've got all my electronics picked out that I'm going to put in it. If you guys follow our Facebook page, then you already know that I've started on this project. And on our Facebook page, I'm posting just about every step that I perform on this. So at the end of this process, it'll be pretty much a complete build log of everything that I'm doing to this airframe and the components and everything I've selected for it. So if you guys are interested in doing a project like this, everything with all the details will be posted on our Facebook page. So I think I put up a couple of new posts in the past 24 hours, I think, that I've been working on this. So the components. Well, first of all, I decided I've got two of these. I wanted to convert one with twin motors, twin tractor motors, and I wanted to convert one with a single tractor motor in the nose with a folding prop and make it a high performance 1 meter sport glider. And I was going to do the twin first, and then I decided, you know, I ordered some prop and spinner assemblies, folding prop and spinner assemblies. One of them that, you know, I picked out specifically for that purpose. And so then I changed my mind, and I was going to first do the high performance sport glider version of it, and then I changed my mind again. So now I'm committed. I've already started the process on the twin tractor motor version. I think that when I get this completed, I think it's going to be an exceptional flying aircraft. My goal for this project is to have the all-up weight under 250 grams. Now that's going to be kind of iffy. I know I'm going to be real close on the all-up weight to 250 grams. But if you guys want to do this project, and I'll tell you why I'm going to be so close on the weight. If I'm doing this project with components I already had on hand. They're not the components that I would prefer to use for this project. The components that I have were kind of overkill, you know, for the way I'm going to have it set up. So, so you could use lighter weight electronic components in this build, and you wouldn't have any problem getting your all-up weight under 250 grams. But we'll talk about that real quick. Okay, so the motors that I decided to use, I changed my mind on the motors too, because I went back and I looked at my thrust numbers on different motors and props that I'd already tested. And I thought, well, if I set it up for 3S, I know I'm not going to hit my 250 gram mark, or my sub 250 gram mark. So I went and I started looking at my 2S test, and I found that these RacerStar BR 1306 4000 kV motors with these diatone 5x3, they're ABS 2-blade props. Now the Gemfan and the diatone props look identical to me, and I've tested both of those and I get identical numbers from them. So it's not going to make any difference whether you get the diatone prop or whether you get the Gemfan prop. But it's the RacerStar BR 1306 4000 kV motor with the diatone 5x3 ABS 2-blade prop. And my thrust numbers show that at full throttle, this single motor is producing 242 grams of thrust. And if I remember correctly, it was around 6.5 amps at full throttle. So around 13 amps for both motors at full throttle. And with the weight of this plane, the all-up weight of this plane, I think I'm going to be able to cruise around with this at about 30% throttle. So even with the two motors at 30% throttle, I think I'm only going to be pulling about 3 to 3.5 amps. So it should not only be very powerful as far as thrust to weight ratio. It should have an unlimited vertical with the components I'm putting on a 2S, not a 3S. And so that's why I decided to go this route with a 2S setup. But it should also have, it should also be pretty efficient. So not only should you have a lot of power and unlimited vertical with your thrust to weight ratio, which should be right around a 2.0 to 1, a 2 to 1 thrust to weight ratio. But you should also be able to get quite a bit of flight time out of it. So those are the motors I selected for it. And then for the ESCs, I selected the FET favorite 20 amp OPTO ESCs. These are going to be tied into a 5 volt 3 amp switching voltage regulator that I'm going to be using. That's tiny, it weighs about 0.8 amps. So the two ESCs and the voltage regulator are going to be pretty lightweight setups, but 20 amps is really overkill for a 2S setup. So if I had on hand what I would prefer to use for that, I would have gotten a couple of 12 amp OPTO ESCs that would have been smaller, they would have been lighter weight. You probably would have saved about 4 or 5 grams of weight with the 12 amp OPTO ESCs as opposed to the 20 amp ESCs. So I would have used that. I'm trying to, I can't save a lot of weight on the components that I have on hand. That's what I've got to use. I didn't want to buy additional components to make this conversion. So I'm trying to shave off every gram I can on the airframe build. So those two. I'm using Hextronic HXT 500 5-gram servos, and again, that's overkill for this. For as light as this is going to be, these 5-gram servos are a bit overkill for it. So if I had 4-gram servos on hand, that's what I would have used. You would have saved another probably between 5 to 6 grams of weight, because they never weigh 5 grams and they never weigh 4 grams, right? But they would have been they would have been smaller and they would have been lighter weight. And so I think you would have saved at least 5 grams of weight using 4-gram servos rather than 5-gram servos. But that's what I had on hand. The battery that I'm going to use is a GMB. It's a 2S 550 milliamp hour AEC LiPo. I've had these for a long time. When I was flying my GFS F-22 Micro part jet, when I first started flying it, I was flying it on 2S. And these are the LiPos that I used in that DIY Micro F-22. I'm going to be using a Byme Gyro and a Byme-A Gyro, if I can fit everything in there, and I think I can. And I'm going to be using a RadioMaster R81 S-Bus receiver, which is a tiny, tiny lightweight thing. So, okay, so what I've done to the airframe so far. All right, so I've cut these channels. I don't know how well you can see this on video, but I've cut channels into the fuselage underneath the wing to bring my servo wires and my motor wires into the fuselage. And there's also a cavity cut, a hole cut out here so I get from underneath the wing into the main canopy area. I've hollowed out a lot of the fuselage, and I did it in steps. So there's a foam ridge that's higher than the very bottom that I've hollowed out, and the reason I did that is because I want to put my receiver and my gyro underneath the battery shelf, and then mount a battery shelf on top of the raised ridge on the side over here. So there's 2 different levels that I've hollowed out. I've also hollowed out as much as I dared out of the canopy cover. I just used some old cardstock material to create a pin and slot at the front of the canopy as a latch, as a latch pin. And then on the back, I'm just going to put in a couple of very tiny little magnets to hold the back of the canopy shut. That, I think, is going to work out extremely well. Also, underneath the wing in the same area where I cut out the wire access, I cut out the center section so that the 2 ESCs will set side by side in a cavity that I've cut out underneath that wing. Because it was just, when I tried putting all the electronic components inside this canopy to see if they would all fit underneath that battery shelf. I wanted my battery shelf completely cleared, except for the battery. I didn't want anything else sitting on that shelf, so I had room to move the battery forward and aft to get my CG. Or if I wanted to use a lighter weight or a heavier LiPo. I would be able to get my CG by moving it forward or aft. So that worked out really well. Having that cavity underneath the main wing worked out really well for being able to mount my ESCs in there instead of underneath the battery shelf, because I mean these take up more room than anything else as far as the electronic components that are going to be in the fuselage. I just used a couple of plastic squares mounted on top of the bottom of the wing, and the way that's going to work is I've got this scrap plastic that I've cut, and it's going to attach to those mount plates that I've got on top of the wing, and then of course the motors will mount to the front of that plastic. I'll reinforce the front of the plastic with some more of this thicker 2mm plastic to mount the motors, but I think that's going to work out just fine. I spaced the center of the motors from the fuselage so that I had room to put at least up to a 6-inch prop on it. Now I'm going to be flying it with 5-inch props, but I like to build things so that it's got a lot of adjustability in it. So if I decided I wanted to use a larger prop, I would have space to be able to do that. So up to a 6-inch prop for clearance on that. Reinforce the wing. The two wing halves on this chuck glider are glued together. It's solid wing now. I have a 2mm diameter solid carbon rod as reinforcement. I went across the center of the wing to reinforce the center of the wing, and then ran carbon rod all the way out to the very wing tip. I wanted to have reinforcement all the way out to the farthest extent of the ailerons to make sure that there was no flexing in the ailerons. The ailerons are installed with hinge pins, and that worked out really well. I also added carbon reinforcement to the tail boom. I cut out a 3mm section out of the center of that little foam skid on the tail. I saved the foam out of the center of that and then glued it back. So this 2mm carbon rod goes all the way underneath this little foam landing skid on the tail, so that it reinforces the entire tail boom, so I'm not going to get any flexing up and down or side to side when I'm actuating the elevator or the rudder. This is going to have a rudder on it. I've got the elevators ready to be installed. I've got to I'm going to install it with hinges. The horizontal stabilizer has been reinforced with a 2mm diameter solid carbon rod as well. The vertical stabilizer, I'm going to be reinforcing it. I'm going to slot it, and I'm going to install a 1mm by 3mm carbon slat to keep the vertical stabilizer from flexing when I'm actuating the rudder. So everything should be nice and solid on this airframe. Nothing's going to be flexing with the ailerons or the elevator or the rudder, and everything will be nice and straight and true. So with the elevator, because the elevators are two different pieces and I needed to pin those together, I'm using the same method that I used on my 48cm chuck glider that I converted to an RC chuck glider with a pusher motor and prop. If you guys have ever watched any videos, flight videos of that little 48cm converted chuck glider, it's a speedy little thing, and it's very maneuverable. Now it's just a bank and yank, it doesn't have a rudder. This one's going to be full 4-channel with the rudder, but the way that I pinned those together, because they were the same way, you know, the elevators were on each side of the fuselage, I just used a plastic sleeve to embed in the back of the horizontal stabilizer, and then I used a steel wire, a solid steel wire. This one has got a 1mm steel wire, and I just made a U shape out of it, you know, and then attached 2 plastic sleeves to the bottom of each elevator, and that's how I pin the elevators together, so that the steel rod will slide in and out of the plastic sheath when you actuate the elevator, so there's absolutely no binding on it. And that worked out just fine. It was the first time I ever did that, so that's the way this one is going to be set up on the elevator as well. So I think it's going to be an exceptional flying converted chuck glider. It's going to be very low drag. It's going to have a very wide flight envelope, and it should have unlimited vertical if I can keep my weight down. I will have links to everything in the show notes. This glider is still $11 delivered for this 1 meter glider. Now, they ship everything in bags these days, right? This was shipped in a bag. I did have to use a hair dryer to apply heat to get the wing. The wing was slightly warped. The fuselage had a little bit, tail had a little bit of a bend in it. Vertical stabilizer had a little bit of a bend in it. But with a little bit of work, I got everything straightened out. Everything was symmetrical. Now I'm just reinforcing everything so it doesn't flex. But for $11 delivered, I think that was a heck of a deal. So even if you just want one for your kids to be able to use it as a chuck glider in the backyard, for $11 for a 1 meter chuck glider, I think delivered, I think is a pretty good price. So I will have links to everything in the show notes, the glider, all the components that I'm going to be putting in mine, along with links to 4-gram servos and 12-amp OPTO VSCs. So if you want to do this project and you use the 4-gram servos in place of the 5-gram servos and the 12-amp OPTO VSCs in place of the 20-amp OPTO VSCs, you shouldn't have any problem hitting your mark at sub 250 gram if you're using the same motors and props, the same lipo, stuff like that, and you modify your airframe the same way and do it as lightweight as possible. You're not going to have any problems getting this under sub 250 gram. So the next time that you see this glider, it will be ready for its first test flights. Now, I have very little time to work on this right now, so it might be another 2 to 3 weeks before I get it completed and ready to launch. But stay tuned for that. So I will continue to post my progress on our Facebook page. So if you guys are interested in that, it's going to be pretty much a complete build log by the time I get done. So I will I know I'll be making another post there in the next couple of days on the progress of this project. So anyway, thanks for watching. Stay tuned. And before long, I will be performing the first test flights on this. I will see you in the air.